So now we're looking at function notation, and this looks kind of weird. Here's what happens. When you get into science, into other things, you might have several different equations. One might be like y equals 2x squared minus 3x plus 4. And the other one might be y equals 5x minus 9. And then you have a third one, y equals 6 times the absolute value of x minus 7 or something. And you might be dealing with all three of these equations in the same problem. And then you're wanting to talk about an equation, and it gets really confusing because they're all y equals. So this function notation, this is really just y. They might replace this y with f of x. So instead of y, it's going to say, oops, let me make that a little bit smaller. They're going to take this y and say, well, since y is a function of x, f of x equals this. And then they'll use a different letter. So this is the function with name f. This one they might say g of x. And then this one they might say, instead of y, h of x. It means these are all functions of x. Y is a function of x. This one is named f, this one is named g, and this one is named h. So this is really like y. We're not going to change it to y because the purpose of function notation is if I have a lot of different functions floating around, which you will in the future, I can tell them apart. So, oops, what's going to happen is one of a couple of things. They're either going to give me x and ask me to find y, or they're going to give me y and ask me to find x. Notice this 15 is where the x is in the equation. So what this means is to take function f and replace the x with a 15. So I'm going to go and say f of 15 equals 9/5 times, again, replacing x with 15, plus 32. So it says if I take function f and I substitute 15 in place of the x, this is going to be 9/5 times 15 plus 32. So not 15 divided by 5 is 3, times 9 is 27, plus 32 is 59. But just to be sure, I'm going to punch that in because I don't want to make a mistake. So 9/5 times 15 plus 32 is 59. Do not divide both sides by 15. This is a notation. This does not mean f times 15. It means take function f, put 15 in place of x, and when you do that, you get an answer of 59. This says take function f and substitute negative 10 for x. So when I take function f and I substitute negative 10 for x, I do 9/5 times negative 10 plus 32. So 9/5 times negative 10 plus 32 is 14. It's negative 2 times 9 is negative 18 plus 32. So this says take function f, substitute negative 10 in place of the x, and you get an answer of 14. That's what that notation is telling me. Now I'm going to move these down here because I need some more room. Notice, here they're asking me to find x. I don't know what x is, so the 41 is not the x. The 41 is equal to the whole f of x. So I'm going to go, and where this f of x is, I'm going to switch 41 in its place. So my equation is going to be 41 equals 9/5 x plus 32. And I'm going to solve this for x. So I'm going to subtract 32 from both sides, and I'm going to get 9 equals 9/5 times x. Now you have a couple of ways to do this, but if you have your calculator, you can just say, well, the way I undo multiplying by 9/5 is to divide both sides by 9/5 and let your calculator do the work for you. And 9 divided by 9/5 means that x equals 5. They asked me to find f of 15, so my answer was f of 15 equals something. They asked me to find f of negative 10, so my answer was f of negative 10 equals something. They asked me to find x, so my answer is x equals something. And again, looking at this, What they gave me was they want x, so they tell me that the f of x has a value of -4, so y is -4. So I'm going to go where the f of x is, and that's going to be replaced with -4. So -4 equals 9/5 x plus 32. I would subtract 32 from both sides to move the constant to the other side, and I would get -36 equals 9/5 x. I'm going to divide both sides by 9/5, which for those of you who know this is the same thing as multiplying by 5/9. And I'm going to end up with an answer. They asked for an answer of x, so my answer is x equals -20. The same thing happens on these graphs. By the way, you're going to see some problems where they're going to have another equation, g of x equals something. This tells me use function f. If they wanted me to use function g, this would have been a g instead. This would say go to function g and put -10 in place of x. Okay, looking at graphs. Again, notice that the -3 is where the x goes. The x goes inside the parentheses. So it says x is -3. So they gave me x, they're asking for y. I go to this where x is -3. I go up and find that point on the graph, and then I go look and see what the y is, and it's 3. So g of -3 is 3. Let's go down here to 1.5. The 1.5 is where the x is, which means they're asking for y when x is 1.5. I go to 1.5 and go down. You know what? We're going to change this because somehow, I don't know why they put this in. Let's do 0.5 instead so we actually have something on the graph. So 0.5 and go down to where the x is. And I'm going to have to estimate. It's somewhere between -2 and -3. It looks kind of actually halfway between. So -2.5. Here it says find the x. If it says find x, my answer is going to be x equals something. Find x, my answer is going to be x equals something. Which means if they tell me to find x, what they gave me was y. So I want to look where y is 0, and y is 0 all the way down here on the x-axis. Notice as I go across, when y is 0, that hits two different places for x. I need to write both of those answers down. So when y is 0, x is -4, and when y is 0, x is also 0. Again, they say find x, which means what they gave me was y. So I go up to where y is 4. There's the point on my graph where y is 4, and the x is -2. So I'm going to change this. My x is -2, and there's only one of those. I might have to do some estimating on my answers. Pay attention though. Did they give you x and they're asking for y? Or did they give you y and they're asking for x?